Hey guys, welcome to the last lesson of chapter 10. Today, this lesson is all about scale factors and solids. Scale factors and solids. Solids refers to the geometric shapes that we've been talking about, like our prisms and our cones and our spheres and whatnot. Scale factors is actually an old lesson that we've talked about a long time ago, and now we're going to see, well, how does it apply to solids? Before we start doing work with all of this stuff, we're going to go ahead and look at the skill check and practice some old skills that we haven't talked about in quite a while. Alright, so here is a skill check problem with problems that have to do with solving proportions. If you guys remember how to solve proportions, we're going to be using something called the butterfly method. Okay, so if you guys remember how the butterfly method works, the first step is you circle the two numbers that are across from each other and you multiply them together. This would become 7 times 4, and you're always going to divide it by the other number. The other number in this case is going to be 16, so divided by 16. Can anything cross cancel? Yeah. 4 and 16 become a 1 and a 4. And our answer is going to be 7 over 4. If you want to simplify this, this can become 1 and 3/4. Now let's go ahead and look at the second problem. The second problem is asking us to do butterfly method again. The first thing we have to do is identify the two numbers that are across from each other. That would be 9 and 24. We get 9 times 24 divided by the other number. The other number is 5. Now looking at this, you can see that 5 does not cross cancel with 9 or 24. So if we go ahead and multiply 9 times 24, I get 216 divided by 5. If I have to simplify this, 5 can go into 216 43 times with 1 left over, or decimal form would be 43.2. Alright, so we're going to be using butterfly method. If you guys remember butterfly method, you guys are in good shape for this lesson. If you guys don't remember butterfly method, well, now's a really good time to kind of, refresh our memories with it. Cool? Cool. Let's talk about the difference between similar figures and similar solids. On the left, or first let's go ahead and talk about the definition of similar. So in mathematics, similar usually refers to having the same shape but not necessarily the same size. Like in this example, these two figures are similar, where they're the same shape. They're both rectangles with the same dimensions, but they're not the same exact shape. This one on the left is a little bit smaller than the one on the right. Similar still refers to the same thing when we talk about solids. Like in this case, these are both cubes, but one is smaller than the other. Now, when we had similar figures before, we would set up a proportion, and a proportion would tell us how to solve for a missing side length. Like if I said this side was 5 and this side was 3, and this side was x and this side was 15, we could set up a proportion, and I could say like 5 over 3, the top over the left, is equal to 15 over x, top over the left. 5 over 3 is equal to 15 over x. Then we can use butterfly method and we can solve for the missing side length. Now, it's a little different with solids because when we had regular figures, these things only operated in 2 dimensions. These would be what we call 2D figures, right? But these guys are 3D figures, meaning they have 3 dimensions. They have length, width, and height. So because these have a few more options, it means that we don't just find side lengths. Sure, you could find side lengths, but now you could also compare areas, like surface areas, and volume. And because surface and area and volume operate in different units, like area is square area, so that's in squared units. And volume is in cubic units. The equations might be a little bit different. So I want to just kind of get this out there that it's going to be very similar, you get it, to what we've done before. But now we have a few more options. And isn't that what we want in life? More options. Well, we got it. Good for us. Let's take a look at example 1, finding the dimensions of a similar solid. The two pyramids shown at the left are similar. So they tell us that they're similar, meaning that they are the same shape, not necessarily the same size. And looking at them, you can see that this guy is larger than the other guy. Find the length of the base edge x. So because they're finding length, whenever you guys are trying to find length, all right, you guys will just use a normal butterfly method. Butterfly method. Nothing fancy about this, nothing scary unless you're afraid of butterflies, which I would understand that. Butterflies are unpredictable. You have no idea where they're going, where they're coming from. You know, I understand that. But this one, not so scary. So, because these are similar and because we're only trying to find lengths, we're only trying to find something that is in one dimension, all right, we can set up a proportion. The proportion I would set up is I can say 5/6 is equal to 12/x. I did the right side over the bottom is equal to the right side over the bottom. The important thing about proportions is that we have to make sure that everything is set up in the right order. So, butterfly method takes place. 6 times 12 divided by the other number, which is going to be 5. Cool? Nothing can cross cancel, so I end up getting 72/5. And if I take a calculator out, 72 divided by 5 gives me 14.4. And because we're just trying to find a length, the answer would be centimeters. If we were trying to find an area, the process would be a little bit different, but we still use butterfly method. The process would be different and the units would be different. Same thing with volume. The units would also be different. Standards check number 1 says two cylinders are similar. So we know that they are in fact similar. The small cylinder has a diameter. So if you wanted to, you could draw pictures, but it's not 100% necessary. I'm just going to go ahead and draw a picture just because. So we have a small cylinder and a big cylinder. It says a small cylinder has a diameter of 4 meters and a height of h. We don't know what that is. The large cylinder has a diameter of 5 meters and a height of 11. What is the value of h? So we're going to set up a basic proportion. I can say 4/h, I did diameter over the height, is equal to the same order, diameter over the height, 5/11. Circle these two numbers, 4 times 11 divided by the other number, 5, is going to give me 44/5, which would give me 8 4/5, or 8.8. Alright, so in this case, the height for the smaller cylinder is going to be 8.8 meters. Now, here's where things get a little interesting. And by interesting, I mean, I don't even know. Alright, let's go ahead and look at this one. Let's take note. From your book, they give you the difference between surface area and volume of similar solids. And the key thing for this one is that you realize that when it comes to surface area and volume, we don't have the same exact rules because we don't have the same dimensions. Remember, area is square area. So whenever you are dealing with surface area ratios and proportions, the surface area side has to be squared because area is square area. And remember, volubic is cubic, so whenever you're dealing with cubic sides, notice that these guys are cubed. So I want you to take note and just to kind of make sure that you have these in your notes. And we're going to be practicing these right now. But whenever you're dealing with ratios with surface areas, it's not just one dimension compared to one dimension. All right, surface areas are square area and volubic is cubic. I think we need to practice some examples just to kind of get used to this idea. So here we have example 2 dealing with the ratios of surface area and volume of similar solids. It says the surface area of the cylindrical pitcher, so this guy right here, it says the surface area is 90 inches squared, about 90 inches squared, and it says the volume is 157 inches cubed. All right, the pitcher and creamer are similar, so these two are similar shapes. Find the surface area and the volume. So we need to find the surface area. We also need to find the volume. All right, cool. The only information that we have to compare the two different sizes would be this guy and this guy, the diameters. And you would look at the diameter saying that this pitcher is twice as big as the creamer, so obviously just divide by 2 and then we have, no, that does not work that way because these are in square units and these are in cubic units. So let's go ahead and just practice looking at surface area. So just a reminder for surface area. All right, let's just compare the units. What do we know about the pitcher and the creamer? Well, if we said the pitcher was 6 inches, diameter over the other diameter, 3 inches, all right, we have to compare it and we want to find the surface area. The surface area of the pitcher was 90 inches squared, and we don't know what the surface area of the creamer is. That's what we're trying to figure out. We have inches over inches is equal to, all right, so can this work the way that it is? Well, not really, because these units are in inches, and these units are in inches squared. So it doesn't work out straight the way it was. Now what we do have to do, as I mentioned earlier, is you have to square this side. If I square this side and square this side, it does actually help. And this gives me a new problem where I can write this 6 inches times 6 inches is 36 inches squared, and 3 inches times 3 inches is 9 inches squared. And now we have all square units. We have inches squared, inches squared, inches squared, inches squared, and now we can do our butterfly method. Our butterfly method says 90 times 9 divided by the other number gives us, in a calculator, 90 times 9 divided by 36 is 22.5. 22.5 inches squared. So the surface area will be 22.5 square inches. Now we can use the same principle that applied to surface area to volume, but now remember volume is in cubic units. So if I said 6 inches for the pitcher over the creamer is equal to the volume of the pitcher over the volume of the creamer, that would work, except these have to be in cubed units. So that means I have to cube these numbers as well. So setting up our butterfly method, 6 cubed is 216, divided by 3 cubed is 27. Butterfly method gives us 19.625 inches cubed for our volume.